welcome to Namespace Podcast. I'm Jordan, and I'm here with my co-host, Derek. Today, we're going to talk about the solid design principles, which is an episode we've probably referenced so many times, saying we're going to have to do this eventually, and finally the time has come, and it's very exciting.
Yeah, it's honestly probably the first one we ever really wanted to talk about was solid.
Yeah.
And just took some time to get there.
Yeah, well, it's an interesting episode, and it was difficult to plan just because, the solid design principles are much more easily explained when you can visualize code examples.
Yes.
So we wanted to find a way that we could share this information verbally, but not be like convoluted or just repeat the articles online.
Exactly. That's why I wrote my own article.
Yeah. So Derek has a really great article, and we'll be making references to it, and you can go check out the article for some more concrete code examples. It's in Python. So, if you're a Python developer listening to this, or, we do a lot of Python stuff. So,
So specifically that article is a Pythonic guide to solid design principles. And it's because they're lacked in that space of Python and solid design. So it was very much needed. And I think it was the first, to my knowledge, is the first article that actually takes all 5 of the principles and uses the exact same snippet of code. And it manipulates it to make it more solid as we go. Every other article I saw was like, okay, well, this section of code is for the single responsibility principle. This one is for Lizkov's, and they have nothing to do with each other.
Right.
And it makes you think that these principles can be used separately, but they're really meant to be used together. They can be used separately, but you really see the power when it's all used together.
Right. Like the benefits that are described, if you're following solid code, mostly like extendability, maintainability, readability, just making better code, you're going to be able to wreak that much better with all of the principles combined. Like they're meant to be used together. So that's why it does make so much sense that in your article, they build on each other as you describe each principle. It's, I think, a better way to show how the principles should be used, because they should be used together.
I couldn't agree more.
Yeah. Cool. So just as an intro, we haven't even said what solid means yet. We could go just through the acronym.
Sure. That's a good idea.
The S is single responsibility. O, open closed. This is like a test, but we've been working on this episode so much.
I know them. I want to make sure you know them.
Lizkov's substitution principle, interface segregation, and dependency inversion.
There we go. A+, Jordan.
Yeah, I have a decent memory sometimes. That's as far as I'll go with that.
That's fair.
So yeah, those are the 5 principles. And what we're going to do is we're going to talk about each principle. Most of the articles online, as mentioned, kind of describe the principle and give an example. What we're going to do instead is try to go a little bit of a different route. We're going to talk about things that you might notice in code that's a sign that the principles are being overlooked. So if these are the things you're seeing in your code, and maybe you have an idea that it's kind of a bad smell, like you see this in your code and you're like, I don't know that I like this, but I'm not sure what to do about it. We're going to talk about how these principles can solve for these different bad smells that you're noticing. And then we're going to talk about why it's important that these fixes are made and why they're good fixes. So yeah, with that being said, let's do a short intro about like where solid came from.
Yeah, we've talked about it, or we've talked about him before, Uncle Bob, Robert Martin. He wrote a paper called Design Principles and Design Patterns.
Yes.
There's a PDF available. We'll make sure we share that out on the episode and on social media so you can actually read the original article. He didn't actually refer to it as solid, and there's more than just these 5 principles in there. And then it was Michael Feathers that came back later and kind of refined that and made the acronym solid. But there was definite things like dependency inversion. Lizkov's was in the original paper.
Yeah.
everybody who knows me knows that I'm a big fan of Robert Martin and his work. And so kind of just pressing on with spreading the word.
Yeah. Okay, cool. So let's go ahead and talk about the first principle, single responsibility, which is a great warm up. Yeah. It's like the most obvious one. And I don't want to say the most important, but you really have to do this one for the others to work. I mean, vice versa for pretty much all of these principles, but this one especially.
Yeah, there's bits of this one sprinkled in through all the others.
Yeah.
Like you need to be adhering to single responsibility. I like this one because it lets me reference my favorite character from MASH, which is Charles Emerson Winchester, because he says, I do one thing at a time, I do it very well, and then I move on. Mm-hmm. And I really appreciate that because that's what the single responsibility principle is.
Yeah.
A function should do one thing, it should do it very well. A class should do one thing, it should do it very well. And then that's like the quick, brief synopsis. We're done. Like just do one thing, do it well. But you know, an example.
And don't do anything else.
Yes, just do the one thing. But you know, there's times where you see it where things are doing more than one thing. So the example I used in my article, I created this example using FTP clients because FTP is really confusing. You have FTP, SFTP, FTPS. Mm-hmm. Which are all different things.
Yeah.
And they're very similar to like SCP, and read the article, you'll get it. But the one I had was there was an FTP client and you would construct it, but you'd have to pass in all the info for an FTP and an FTPS connection. Mm-hmm. And then in the upload or download calls, you would actually have to switch between it. And the parts that were wrong there was that this class was maintaining two different drivers, like the underlying code that actually performed the upload download, because those third-party libraries can change on their own. When calling the class, at the time you're calling it, you know already if it's going to be FTPS instead of FTP. So why are you passing in a parameter that's going to switch between it? Like you just call the FTPS upload instead of FTP right. Client upload is FTPS, was kind of the point there. And so there's all these things where you had reasons to change. And that's officially what, or I shouldn't say officially, but that's how Robert Martin, Uncle mm-hmm. Bob describes it. He says it has one reason to change. So all those things I was talking about were different reasons to change, and they could change in different directions. And so the snippet looks really clean and simple, and it's like, oh yeah, that's a decent abstraction, and it was. But as things grow more complicated, that's when you start getting these nasty nested if else cases, do this, oh well, a little hack here and there. Mm-hmm. So if you just start off at the beginning, like do your single thing real well.
Yeah.
No. Is there any other examples that you've seen in code that you want to talk about?
Yeah, there is one actually that I thought would be a good one to talk about. Really quick though, I wanted to say kind of a definition that I have in my head that's a good way to identify, I think, single responsibility that I was thinking about. Just the idea that if you're explaining your class to a developer or you're explaining your function to a developer and you hear yourself say, well, it does this and this, well, now those are two responsibilities. So that's another kind of good way to think about it.
So is it okay to say that my FTP client class uploads and downloads?
I actually was thinking about that when you were talking. And it's like one of those things where, again, you don't want to be too dogmatic. I mean, two public methods in a class is not like an influx of responsibility. I personally, most of my classes that I make have 1, 2, or 3 public methods, like maybe a factory method and then a do your thing
Technically,
method.
You write Python, so you write more than that. You just claimed 3 are public. Underscores don't count. They're still public in Python.
Well, yeah. I mean,
I'm not letting you off easy. You came at me. So I can agree with that. When you're starting to explain your thing and it's like, oh yeah, it does this and this and this and that. It's like, okay, hold your horses.
Right.
the example of the FTP client doing upload download, I think of the higher abstraction, which is file transfer. What does this class do? It is responsible for file transfers.
Right. Yeah.
And so
that's its responsibility.
What are things you can do on a file transfer? You can upload, download, you could delete, create possibly. And those things are okay because they're actions on the abstraction, not different abstractions. And so it's like, oh, my FTP client handles FTP connections and FTP. That's bad. But my FTP client uploads and downloads, it's two separate things because it's actions versus abstractions.
That's a good point. I mean, each of your functions has, or I guess methods has a very specific responsibility, like within the class.
Yes, exactly.
So yeah, that's kind of an overview. The example that I thought that was good, kind of bases off of one of these bad code smells that I was going to talk about. So, I think this is a good way to identify, like a single responsibility, not being done in a code base. If you have subclasses that are inheriting from parent classes, but the subclasses don't actually need all of the logic that the parent class provides.
I think that's better to say for Lizcovs.
It is good for Lizcovs, but it's also a way to identify that the parent class has two responsibilities. Oh,
yeah, right. Yes, that is a very good distinction. Your parent class would be bloated, is what I would call it. Yeah.
Yeah. So and now you're starting to see how they tie together. I mean, that's a terrible. Yeah, that's like you're breaking Lizcovs, but also you're kind of the parent class is kind of breaking single responsibility.
Well, as you think of the inheritance hierarchy, you have the parent class with two responsibilities. One responsibility needs to get more specific. And so you can still follow Lizcovs because it's going to inherit all that other junk into it.
Right.
With this more specific case. But the more specific case didn't care about all of that. And so that's why single responsibility is really important. You don't want all that bloat floating around because now all of a sudden you have a parent class and a subclass. That subclass is being used over here in module C. The parent class is used in modules A and B. And there's a bug fix for module C where you update one of those parent class functions. Now all of a sudden you have this subclass that's breaking Lizcovs.
Yeah.
And it's hard to tell. It's hard to see that in a code review if you're new to the code base, that kind of stuff.
Yeah, it does get complicated. Like I almost want to talk about interface segregation a little bit because that's another way to kind of solve for this. I mean, in Python, your parent classes are almost interfaces a lot of the time. But anyway, I guess the very specific example that I was thinking about for this was we had a database model class, which, well, first of all, it wasn't a database model. It was like a database interactor or something, like a database connector.
Continue to make more terms.
I know.
This is a code base that I wasn't a part of, so I don't know what you're talking about.
Oh yeah. Well, so the idea
it wasn't one of the code. It wasn't from the code base we worked on together.
No. But the idea was that the database model class was doing inserts into the database and exporting from the database. For this specific use case, those two things really didn't need to be in the same class because we only had certain things that were needing to be inserted and certain things that needed to be exported. So we did have a bunch of subclasses that were inheriting from this database model, which is really like a database interactor again. That's how a lot of people refer to models. Like in C# entities framework, your model is a object representation of the record in the database. And so and Laravel does it too. But that's not
Django
what this was.
does it. Oh, that was okay.
That's the thing, because I think of a model as like a representation of data in a database. This was a representation of a database. Like it was like you call insert on it it doesn't have data in it at all. It's not modeling data. It's modeling.
So instead of like having a user model and you'd say user.create or just create a new user that adds to the database, this is database.insert new user. Oh, yeah.
Right. So that's not really a model. I don't know what to call database interactor. Kind of sounds stupid. And anyway, I just keep having to clarify. So anyway, so the database model, maybe to me not a model, but it was doing inserts and exports. And so if you were using the insert logic, the subclass would have to specify different things like the table that it was inserting into, and then also the fields. If you were inheriting from it and trying to use the export functionality, I guess I don't remember exactly how it worked, but it was like you had to define different things based on how you were using it. So it was like some subclasses would be using the insert properties or the insert method. And if you tried to call the export method, it just wouldn't work because these subclasses weren't actually...
they would like put a not implemented to overwrite the parent or something.
Yeah. So there were...
That's terrible.
Right. There were issues. And I mean, now we are really seeing how Lizkovs and single responsibility tie together big time. And we're going to talk about Lizkovs. I mean, we're on S, O, and then L, so we're going to get there. Right, but yeah, it's like what I was just able to kind of identify, like, these subclasses don't need all of this logic in this parent class. This parent class has two responsibilities. So that's, I think, a good example of a bad code smell. And then there's some more obvious code smells, like the low cohesion in a class when it does all these different things, but they're not really things that are related. Like upload and download are related because they
transfer files.
They're part of the same abstraction of the FTP, like client driver, whichever one it was. But
well, you have this thing of I need to move files.
Right.
You can upload files. You can download files. Arguably, creating a file could be a little outside of that. Like, it's not file transfer. At that point, it's file creation, file management. Moving a file from one directory to another, that wouldn't really belong in the FTP client because, well... Okay, in the article, it eventually gets down to the point where it's called a file transfer client, and you have different versions of the file transfer client, but it's transferring files between hosts, different servers, not different directories on that server. Those are different use cases, and so they seem very related. Like, oh yeah, it's file management. Like, why not stick it there? That seems reasonable. Some of the code may be reusable, but it's like they're different things. And so that's the cohesion. It's low cohesion at that point.
Yeah. And all these things, like, this is kind of, it's difficult because it is kind of opinionated. I mean, there are arguments to say they are related.
But my opinion is valid.
No, I think it's right because you just want to go for what's most simple. So if you start defining too many methods, you got to kind of identify, what can I differentiate here? What can I turn into its own responsibility? At least that's what I like to do. If something starts becoming too complicated, I'm like, what can I do to separate this out to make it more cohesive? And I mean, it is kind of an opinionated process, but you just want to make it look pretty, right? Just kidding. But that's
there's something to be said for elegance.
Yeah, it's like if it starts looking really bad, that's a problem. If it starts feeling confusing, that's a problem. So start really thinking about your responsibilities at that point.
Right. How are we doing on time, real quick? 4:30. Okay.
We can move on to the next one. I think the only thing to say here about, because the only last section would be like why it's important.
I think we've demonstrated that.
We've really demonstrated that, I think. But just to recap that, it's like much easier for other developers to understand the code if it only does one thing.
Okay, now you said that. Now I got it. So there's this burning thing in my soul that I just have to say.
Okay.
When I was taking my university classes, one of my professors said it is far more important to know how to read somebody else's code than know how to write code.
Yeah.
And it's so entirely true. And it's, in fact, our entire interview system is broken because we interview on the ability to write code, not the ability to read code. And 90% of the issues that happen is because people don't stop to read the code.
Yeah.
Probably because it's complicated and hard to read because they didn't follow the single responsibility principle. And so then they just write more code that then is starting to redo some responsibilities instead of reuse.
Yeah.
And so anyhow, the reading of the code. One, people hate reading code. Jordan hates reading code. I hate reading code. You hate reading code.
I like reading my own code.
Right. We all... Sorry, shit doesn't sting. But... So the point is, though, I've worked at plenty of companies and I've seen plenty of code bases where it's like, wow, you didn't stop to read what the previous code was doing.
Yeah, exactly.
And you just caused so many problems. And so as a good developer, like if you're aspiring to be an architect, team lead type developer, this is one of those you lead by example moments. Following the single responsibility principle makes your code more readable, more understandable, more efficient, more just to the point. Mm-hmm. And people are going to recognize that. I'm like, wow, that wasn't so bad reading code. I don't mind reading his code again. 2, I want to be able to do that. I want people to have, because as humans, like psychologically, we like to do things that make us look good. Mm-hmm. We like to talk about things that make us look good. We don't like talking about the things that don't. And so this is one of those things you can do. It's going to make you look good, and people are going to want to, talk about it because it makes them look good that they're able to do it and they recognize it. And okay, sorry.
No, this is a
tangent, but
I was going to say, like, this is a really great tangent because I mean, I would say not all tech debt, because some tech debt is just caused by laziness or like not having as much experience, right? But you can also, I feel like most tech debt is because people didn't read the code.
Yes.
So it is super important. And these principles, I mean, as we say at the very beginning, a huge benefit of following this is greater readability and easier to modify, which they tie in together, because to modify code or extend upon it,
you read the code to modify the code.
Yeah. Okay, cool. Yeah. So that's like the simplest responsibility, but I want to say it's the most important, and because it does tie into all these other ones so well, it's really good to start talking about the other ones as we kind of did. Yeah. But I think single responsibility ties in really well to open closed. Actually, the open closed principle is next, which I think you had an interpretation of it that was slightly different from mine. And I think that they're both really great interpretations and they're both valid. Kind of what I've always thought is that the open closed principle means that you should only have to change code when the actual business logic changes. And then in your pull requests, for the most part, you should just be adding new classes, sometimes new functions or methods, and then have like small refactors to integrate your new classes or your maybe new methods, but mostly just adding new classes to integrate that with the existing code and the existing patterns. Which I think is definitely one way to think about it. Like if you are following single responsibility principle and all of your existing code already has their own little responsibilities and you're implementing a new feature, for the most part, you would probably just need to either create a new interface or start adhering to an existing interface to fit into the code base what you're trying to add. Like you wouldn't have to go in and change this 100 line function and make it a 200 line function. Like you wouldn't want to do that.
A code smell of its own.
Right. You don't
50 lines. You get 50 lines for a function. You're done.
Okay. Actually, yeah. So
done.
And the thing on that I'll say is I agree you don't want functions that are too long, but I also hate whenever I see like people taking a really long function and breaking it up in ways like
where each function is a single function call of its own.
Exactly.
And too much context switching. That's a terrible code smell as well.
Exactly.
Because there's a balance on both sides.
There's definitely a balance because you do want greater basically you can, as a developer, you just need to consider what's going to be most readable whenever you're breaking up a function. You don't want to break it up with the thought like, oh, well, maybe this can be reusable, because if it's don't solve for use cases that don't exist yet. But if it,
oh man, I love that. Oh, don't solve for use cases.
I love that too.
It's beautiful.
Yeah.
As I like to say, nobody likes a dry pastry.
Yeah.
So we all know dry, don't repeat yourself. Plug here. I'm going to be creating a article. Nobody likes dry pastry for please always stop to repeat yourself.
Yeah, that's important.
And it's exactly what Jordan just said. I'm totally going to rip off that line. Don't solve for a use case that's not there yet.
Yeah.
Or as I say, program for your use case, not your reuse case.
Yeah. Yeah, it sucks. I see people like putting this extra code because they're like, it'll be useful later. And I'm like...
And then they label it as an abstraction and you just want to condemn them.
I mean, the worst part is when they don't test it, and then it's like, why are you're making more work for yourself? Just don't try to do this extra thing.
Of course.
It's just extra code to maintain for no reason now.
So I hope I didn't I agree with you 100%. I hope with what I was saying, I didn't derail you. Were you done with your explanation of open close?
That's what I thought. You had this thing about calling code changing. Yeah,
so the open close principle, fully written out, is a class is open for extension but closed to change. Mm-hmm. So when you think about that, what is a change versus what is an extension? And so it centers around the use case again. If the use case is transferring files to an FTP server, a change in use cases, well, we need to transfer files to S3 instead, an S3 bucket in AWS. But an extension is like FTP, and now we need to support FTPS, which is the secured version of FTP. Mm-hmm. And when you think about how your code is written, what is a change versus what is an extension, the way I broke that down was a change is anything that forces calling code to change. Mm-hmm. So if you have modules A, B, and C, they're using your FTP client. If you add something to a method declaration to your FTP client and modules A, B, and C have to change for what you were doing for module D, which was the driving force behind the change to FTP, that is a change. But there's things like adding default parameters, adding keyword args in Python, changing parameter names, is a more obscure version of that.
Like adding a new class or a new method is extending.
Exactly. So that's an extension of what you've done. It doesn't force A, B, and C to change how they've interacted with your FTP client. And so that's how I kind of split apart a change versus an extension.
Yeah, I think that's really good. Like, the thing I thought about that is if you're having to change your calling code, what's kind of really going on is you have maybe poor encapsulation. Like the calling code might be having an idea of what's going on in the function because it's having to change its behavior based on what the function is doing. So if you're encapsulating logic really well and maintaining responsibilities and maintaining cohesion, that's a good way to write clean code.
So it could be called a leaky abstraction.
Yes.
The FTP client would be a leaky abstraction because it's leaked out a detail of what it's trying to abstract. We can take FTP, FTPS again. Mm-hmm. If A, B, and C have just been using FTP, but all of a sudden, vendor D only supports FTPS. And so you add the is FTPS flag to your FTP client. If you don't default it, A, B, and C now need to be changed to say is FTPS equals false, and they've now leaked out an abstraction that FTPS is a part of that.
Yeah.
So I think you're totally right. I think the difference is yours was a little bit more practical and in the code, mine's almost more theoretical, general how to classify things. So I don't think the definitions conflict at all.
Right. They don't conflict.
I think they're different levels of granularity.
Mm-hmm. For sure. Yeah, I'm looking, another kind of bad smell that I was thinking of has to do with open closed. Just whenever you see a whole bunch of conditionals and you anytime you want to add something, you have to keep adding to those conditionals. It's you're continually modifying some function when it would be better to rather than having a bunch of conditionals to have different classes that have a method defined, and then you can do more of a strategy pattern type thing where you pass in the right class based on.
See, and that actually takes you more to the single responsibility principle. If you have all these conditionals to decide things, this one object is having multiple responsibilities.
Yeah.
So break those responsibilities up into their own classes, and then that conditional goes away.
Yeah.
And actually, Uncle Bob just went on Twitter and talked about that exact use cases. Switch statements and if-else chains inject a lot of dependency into the code base, and all those dependencies are pointing to details instead of abstractions.
For sure.
And that's when we get to the dependency inversion. Like
it
that's
does
really
tie into that.
Yeah, that's exactly what you want to get to. Is you want to point to abstractions, not details.
Yeah.
So yeah, what you were talking about with the if-else is totally a code smell.
Yeah.
I think the single responsibility principle is the solution to it more than open closed.
Well, yeah, the solution, I think it's a code smell that you're not doing open closed right, just because you're having to modify this function all the time, and it's like kind of changing the function versus like adding a new class or adding a new method. But the solution, I agree, would be better responsibility handling. And now that you've mentioned it, I think the best solution is dependency inversion.
100%.
So we'll get to dependency inversion at the very end. So now you can't turn off the podcast. There's too much anticipation.
Right.
You're really excited.
It's because dependency inversion is the best.
Yeah.
One other thing I want to say on that, the biggest code smell you're going to see is when making an update to a class or something that's causing a lot of changes to calling code.
That's the biggest
principal one you
smell.
see. If you see a lot of cascading changes like that, open close isn't being followed, and following open close is going to save you a lot of time. It's going to reduce the area of effect on the code base for bugs to seep in. It's going to make pull requests smaller, more focused.
Definitely.
I think open closed is one of the most crucial ones.
Me
because,
too.
Yeah,
We're going to say this about everyone.
But that's the one that's like, man, if you really get open close down, you really understand it, the quality of code of yours that's going in, I think, just skyrockets.
Yeah.
Now, Lizkov's is my personal favorite. And it's probably because it's the only one I learned about in school.
Oh, okay.
And it's fun to say Lizkov's.
Well, and it's the most confusing when you just read like the textbook definition of it.
Right. Do we actually have that written down? Because I don't.
No. It would be. I think it would be too complicated to say because there's like, like
T of P and F of P. And
there's like
subtype S.
Mathy stuff.
Yeah, it's
look it up.
So Lizkov's proposed by Barbara Lizkov back in like the 60s or something. This was a long time ago. And shout out to female coders. Where'd you go? Like one of the.
We're all here.
The definite right. We have one here. But yeah, Barbara Lizkov, female engineer back in the 60s, came up with this principle. It's a very formal definition. It's the only one that has an extremely formal definition, which I agree. Let's not read because I don't think we wrote it down and I don't remember it exactly.
We could pull it up, but just look it up yourself because I think we would. We'll just say our interpretations.
Lizkov's is very well defined.
Yes.
But what it's saying is objects of a subtype should be able to replace an object of their parent type without any change in functionality.
Right.
That's Lizkov's. That's the Derek definition.
Yeah. And then if you think of, if you take that and you think of, I guess, more specific code, how you would do that in the code, it's like you need the methods of the subclasses to have the same function signature, right? Like they need to take in the same number of parameters. Each parameter needs to be the same type. It needs to represent the same thing, basically, because you need the functionality within each subclass method to do the same thing. Like they all need to do the same thing. Yes. So if for one method in a parent class, all of the subclasses that are implementing that method need to do the same thing.
Exactly. And so I've alluded to switching use case to using S3. So you can follow the open close principle like, I'm going to create a subclass of FTP client, which is an S3 client. And that's then going to upload to S3. But then all of a sudden, like the functionality changed. You didn't upload to an FTP server. It's at this S3 bucket. And S3 really isn't a special case of FTP.
Yeah, that's true.
The special cases of FTP is like SFTP, which is different than FTPS. SFTP is more centralized around like SCP, and FTP is more around like HTTP, HTTPS. Regardless, I did a lot of work with FTP servers at one point in my life. Can you tell?
Yeah, I can tell.
But yeah, so you may have the same method signatures and all that kind of stuff, but like the actual functionality is changing at that point. But you were totally right to say a subclass has to match the function signatures as its parent. Otherwise, when the child replaces the parent, your code just blows up.
Right.
And so, for statically typed languages, types are super important. In Python, PHP, JavaScript, you can kind of get away with it.
But if
I don't recommend it, but you can.
Yeah, it's like even in Python, you would still, if you want to follow Lizkov's, I would say, and I don't know if this is up for debate, but I would say it has to, even in Python, be the same types. But I'm very into type hinting lately, and I don't know.
I was actually just a part of a project where they absolutely passionately demanded type hinting be removed, so usually I'm all for type hinting too. But it's because a bunch of C# developers were porting code over to Python, and they were thinking that there was safety nets with those type hints that weren't actually there.
Right, yeah.
And so it was causing a lot of problems. And so that's the reason it got removed, is it took that knowledge of a different language and kind of removed the ambiguity that type hints in Python don't actually do anything.
Right. I think more than anything, it's good documentation for other developers. I mean, that's 100%. Why I like it.
But in Python, let's think about this. Like, you pass the string 1, 2, 3, 4, or you pass the number 1, 2, 3, 4. Python can handle both of those.
Yeah.
It's a different type, but are we still within Lizkov's?
Right. I mean, I think...
That's why I'm saying you can get away with it. This is back to our don't be too dogmatic.
Yeah.
Which I think that could almost be the name of the podcast. Don't be too dogmatic.
Yeah. Or our like catchphrase or something, but
could be.
I mean, it kind of is our catchphrase, but
besides the point. I feel like I derailed us once again. I'm sorry. So sorry.
No, this is kind of, we're here to talk about Lizkov's.
All right. So
we were talking about Lizkov's. We're doing
Let's talk about the thing that almost shattered my world, my life.
Oh, yeah, I know about this.
Okay, so on my article, somebody made the comment that said, your constructor doesn't follow Lizkov's in my FTP example. And I woke up one morning to this, and the bottom of my world just fell out. I was like, what do I do? Like, did I screw up this entire article? Am I a sham? Do I not know what I'm talking about? And so I really thought about it. I really dug into the definitions and existing explanations. So I think I am still right. I'm correct, because the formal definition talks about objects of type this. You call the constructor which forms the object. So
the constructor doesn't necessarily have to follow the same, like the parent and the subclasses.
Well, because once you have the object, you're not calling a constructor on it. It would produce a totally different object. And so I think I'm still right, but Lizkov's being so old, I'm not even sure what languages were out that were dynamically typed and if there were OO at that point. But I would suggest trying to keep the constructors following the same method signatures and stuff.
That's what I do. I always have the same function signatures.
I think that's going above and beyond. I don't think it's required to be Lizkov's compliant.
Yeah.
Well, good on you. Good on you.
No, I was just thinking about something.
Just stop thinking.
No, I was thinking.
No, I'm right. Just say, Derek, you're right.
Huh. I was thinking, because what I've been doing lately is like the factory method thing where...
Yeah, the factory pattern.
Yeah, so rather than calling the constructor directly, like a class method that takes in different parameters and then based on these parameters figures out how to call its own constructor. So like, for example, the one that I did lately was I made these error response objects so that we could have for our REST API, like very standard error messages. So if it was an error response object, I would have a subclass that's like immutable field error response. And I have a method create single response that will take in a all it needs to take in is the field name. That way I can create, like, what's it called? Concatenate a string that says this field name is an immutable field. And then it will pass that message along with a 409 status to the actual constructor. So in this way, I have my error message parent class constructor, which just needs a message and a status. But then the subclass kind of encapsulate it encapsulates what that message looks like and the status. And then all that you would pass into the create error response is just the detail that needs to be embedded in the response. Now, every time there's an immutable field, it looks the same, which is beautiful. But now
I would be very intrigued to see the code. Like, I think I'm following it, but I think seeing the actual code.
I'll show you. But the thing is,
is it something we can share with them? Probably not.
I wrote it for work, but it's like very vague. I debate that kind of stuff all the time. I know. It's just
usually the way I do it, screenshot. I'm like, oh man, look how pretty this code is, as long as there's nothing like work.
Yeah, because this is it's so vague. But the other, I guess now consider this. It's like
consider the following.
I'm trying to think of another example of a different type of error response.
So I feel like I know what you're talking about because I did something similar. I wrote this piece of code that works with a bunch of different products that provide classifications for malware threat data. And you have like the root product result type object. And based on which product calls that, it knows how to construct like a specific, this is a SS deep product, or this is a virus total product or something like that. I can talk about those because those aren't work specific. Those are things anybody can go out and use to analyze malware. But I feel you. There was a class with a constructor, and that constructor acted like a factory for subclasses.
Yeah. I just realized, though, that I was following Lizkov's because I did like a star args thing in the parent.
Okay. I want to see
this is getting so convoluted. No, but
we've debated about having a whiteboard or something where we could like draw out.
Yeah, because we do have YouTube. I just don't want it. I don't want the people who are like driving to work to be missing out. Nobody's driving to work anymore, but
that's right. I wake up, I roll out of bed. I'm like, oh, computer. Blah.
But yeah, what I was just considering was that I was worried that I was doing this factory method thing so that I could avoid having constructors that did not follow Lizkov's, because I wanted my subclasses to have different variables that are required to initialize them. And I thought, okay, well, I'll just, the init can look the same. The init just needs a message and a status, but the factory methods that construct the objects will take in what that specific subclass needs. And I started thinking, like, did I just move my Lizkov's problem from the init to the factory methods? And I realized, I guess I just realized that I wasn't breaking Lizkov's, because I don't know what you would call this in other languages, but I did like the star args thing, which is like the ordered, what was it called? Like the ordered parameters, like ordered optional parameters. Yeah.
So you have positional parameters, which is the specifically named one.
And then optional
args, which is optional.
Positional. I think those are the optional positional.
Yeah, there is a term for it, and I can't remember what it is now. And then you have keyword args, which is KWRs, but
optional
your
keyword.
optionals.
Those are optional but not positional anymore.
Yeah.
Anyway, so I hope you guys enjoyed that convoluted discussion about.
We're gonna figure out a way that she can share it or she can rework it as
I think it's a beautiful chunk of code.
Well, right, but so you wrote it for work, but if you can come up with an example that's similar, that's not work related.
Literally, it would be a good pattern for any REST API. It is this little snippet is completely generic. I could put this in like one of my personal projects, and I mean, how do we? Am I allowed to share it? Anyway, we shouldn't talk about this too much. That's up to you and work.
I don't know what you're allowed to share.
Let's see what, I guess we could finish LizCovs for the next episode. But let me see if there's, I don't know. Is there anything else you want to get into right now? Because we do have some other code smells that we want to talk about in terms of LizCovs, but
how many do we got?
We've got, well, I mean, these are just directly breaking LizCovs, but the conditionals on the function parameters and to do the functionality or to not do the functionality might be a bigger conversation.
No, I think that'll be quick.
Okay.
Go into that. Yeah.
Okay.
I think we polish off LizCovs and then we do interface segregation.
Okay, cool. Yeah. So the one other, I mean, there are some bad smells associated with LizCovs that are literally you're just not doing LizCovs, because LizCovs is very clearly defined. So it's undebatable in certain cases when you identify that LizCovs might not be done properly.
100%. If parent class expects 3 parameters and child class expects 2, you've broken LizCovs.
Yeah. So
done.
There are those smells, which, maybe the code is still working, but it won't work if you want to do like a factory, or if you want to do like the strategy pattern. But then the other thing that we were talking about, which is a really good identifier for breaking LizCovs, would be if you have methods and one of your subclasses decides to do this. Your subclass
code thinks for itself sometimes. I mean, I've been there.
The subclass is doing a conditional on one of its parameters and looks at the parameter and decides then, okay, should I follow this execution path or should I follow this other execution path? Like, should I do the thing that all the other subclasses are doing, or does it actually not apply to me?
So this was actually part of the Zen of Python that I used for LizCovs, is even the special cases aren't special enough to break the rules.
I love that, Zen.
And boom, there you go. So yes, that is total violation.
Right. Yeah, because it's, I mean, the issue here is that, I mean, if it's not apparent, like we've already discussed this, the child class needs to be able to replace the parent class in any circumstance. And, the functionality for the methods, if each of these subclasses has the same method, right, then they all need to do the same thing. So if one of your subclasses all of a sudden is like, well, I'm going to do it sometimes, but sometimes like I'm going to do this other thing, that's breaking LizCovs. And I guess in terms of why it is important, I mean, for one, it just comes down to readability and making sense. 2, it's like, well, if you are trying to do a strategy pattern type thing and you call a method and the code is supposed to not care about which object what the method was called on, well, now maybe it does care, because maybe now you can't respond. You can't have like the code that follows calling that method. Maybe now there has to be a conditional there because it doesn't actually know if the thing got done or not, because some of the subclasses are doing it and some of the subclasses aren't. So the idea is you want to make sure that
it's preconditions, postconditions.
It's that thing. Yeah.
If you meet the preconditions, the postcondition is also met. If you have one subclass that the preconditions are met and it decided not to do the postcondition, which is the result, the side effect, whatever you want to call it.
Right.
Like,
yeah.
Something down the line is going to blow up and it's going to be spooky accent at a distance. You'll be like, well, why is that failing? That should never happen. Mm-hmm. It's because this is one design flaw in a subclass.
Because you had this special case that you thought was special enough to break the rule.
That's right.
It's never special enough.
Exactly.
But yeah, if you don't know about the Zen of Python, if you're not a Python developer, it totally still applies. It's like a very great set of theoretical ideas. Like Solid to me is like every time I'm writing code, all I'm doing is thinking about how can I write this in a way that's solid. The other thing I've
trained you well.
Oh yeah. And then the other thing that I think of is the Zen of Python. Sometimes I'm just like, it's more vague, but it's very beautiful. I love the Zen of Python.
It's very specific to Python too.
Is it?
Solid is much more about software development as a whole. Zen of Python.
OOP.
Yeah. Oh yeah. Oh. Arguably it could be used for functional, but we're not going to go into that.
Whoa. Whoa.
Right. But yeah, the Zen of Python, one, it's got a lot of jokes in it and Easter eggs. I will send you an article that actually explains some of those.
I think I probably read it last week, but send it to me.
Yeah.
The Dutch Easter egg thing.
Oh, kind of. So like one of them is it's PEP 20 because it's the 20 Zens of Python and there's only 19.
Oh, that one. Yeah. I've heard, I read about that one last week actually. So maybe it was the same article. You should send it to me. Okay. I love the Zen of Python. I'm totally obsessed.
It's really good. I wish every language had one. We just found out that Go has one.
Yeah.
Or somebody created one for Go. We don't do as much Go, so we got to think about it. But
we're not really gophers.
No.
I don't actually. The only Go I've done is read Derek's article.
It's a good article, man. I put a lot of work into that.
Another plug though. Derek has a Go Python comparison article, which is really, really helpful.
Technical deep dive.
But yeah,
I taught myself Go over a weekend.
If you know Python, and you're interested in Go, this is literally your only chance to. I'm just kidding.
Your only chance to ever read it before I delete it.
You have to read it.
So flattering. Thank you.
But yeah, let's see if we want to finish Lizkov's. I'm not sure. That might be everything.
Yeah, we've definitely hammered home why it's important.
Yeah, totally. Yeah, I think, I guess the one last tidbit I had about it is the farther you stray from Lizkov's, the harder it is for other developers to understand what a method is for.
I would say it's also probably the hardest to undo. Maybe dependency inversion.
I think dependency inversion is the hardest one to undo.
But yeah, Lizkov's, the more you start breaking it, detangling that inheritance hierarchy gets nasty and it causes cascading code changes. And so just follow it. Yeah,
it will allow you to actually do like design patterns. And
this is true.
You really need to do Lizkov's to confidently implement design patterns.
100%.
So yeah, I guess let's end it here. We're gonna do a little bit of a cliffhanger.
So sorry.
Yeah, the last two are great. We'll talk about interface segregation and dependency inversion, and then I guess we can also do a little bit of a recap conclusion thing in that episode.
Absolutely.
So. Okay, great. Well,
thanks for hanging out.
Yeah, thank you so much for listening. Catch us for Solid Design Part 2 coming up soon.